Lesson 07, perimeter. The definition of perimeter is the distance around a figure. So we're going to start by talking about the most common figures that you guys will deal with this year in algebra. Probably the most common is rectangle. And I'm just going to cover what the formulas are, and from this point forward then you are responsible to always know them. So rectangle, the perimeter is 2 lengths plus 2 widths. Anytime you're given something about a perimeter and a rectangle, I would think you'd want to go ahead and write that formula down and then always plug in what you know about that. So perimeter for rectangle, 2 lengths plus 2 widths. For a square, since all of the sides are the same, you could use the 2 lengths plus 2 widths, but that's kind of silly. Since they're all the same, you're going to want to say perimeter of a square is 4 times s, which is the length of a side. Alright, so you need to know always and forever, rectangle and square. Parallelogram. Now, when you look at a parallelogram, they're going to give you 3 measurements normally. So remember, for a parallelogram, it's kind of a rectangle that's been pushed over a little bit because it doesn't have the right angles. And they're always going to throw in this measurement because it's pretty important, the height, but you don't need it for perimeter. It's going to be very similar to the rectangle one. Instead of length and the width, they're just going to give you 2 measurements, A and B. And parallelogram, same as a rectangle, opposite sides are the same measure. So perimeter of a parallelogram is 2 A's plus 2 B's. Same kind of thing. Alright, so if you're given some of those, plug those in and solve. Occasionally they might give you the perimeter and you have to solve backwards to find the length or width. Okay, that would be just solving equations, and that could happen throughout the year. All right, I'm going to concentrate a little bit more on circumference. This is also something you need to know from this day forward. Circumference is the distance around a circle. So it's given a little bit different name. It's perimeter, but it's, since it's a circle, it's called circumference. So in circles, here are the terms that you need to know. These are in your standards. So in a circle, you have the center of the circle, okay, which would be right here. If I can get it to draw, I'll put a center in that circle. Maybe. Oh my goodness. There it is. Finally. There's the center. All right, so first of all, from the center out to a point on the circle, anywhere around there is called the radius. Radius is a measurement of a circle. A lot depends on that radius. So from the center of the circle to a point on the circle, that's called a radius, and that can be anywhere around it. Next, from one point on the circle through the center to another point on the circle, that's called a diameter. That's how circles are measured, by their diameter. Notice for over here I've got biggest chord, so we better talk about a chord. A chord is any segment in a circle that has both endpoints on the circle. So this little segment over here, okay, this one that I'm referring to, it has an endpoint here and here. It's right here. Chords can be any length in that circle. And there are an infinite number of chords in there, basically, and all different sizes. But the diameter is the most important one because it goes through the center, and it's definitely going to be the longest then. So it's important to know the diameter is a chord, but it is. All right, a long time ago, these mathematicians, they were sitting around and discussing and talking about circles and all these measurements, and they did all these studies, and they discovered that no matter how small or how big a circle was, if they took the circumference of that circle and divided it by its diameter, every time it came out to this value. 3.141592654, and I believe some of you in our pie contest last year probably know a lot more digits than that, but it came out to the same thing, and that's when they decided that that must be really, really important. That number must mean something, and so they decided it was so important that they gave it its own symbol and its own name, and that's how pi was discovered. We, of course, do not use all those digits. It's one of those irrational numbers because it's a decimal that never ends and it never repeats the same digits. That's why it's irrational. We are told just to use 3.14. If you are using a fraction, or if you're given a fractional measurement, you should go ahead and use the equivalent 22/7. It makes it a lot easier. So when you take, hang on just a second, when you look at the circumference divided by the diameter, and that equals pi, well, you can easily take both sides of that equation right here times the diameter, and you know that'd make the diameters fall out, and that's where we get this formula. Circumference is pi times diameter. That's how the circumference formula was developed. It's pi times the diameter. We use 3.14. Now, if you're given the radius, of course, the radius and the diameter are related. For every one diameter, it takes 2 radii. So an optional formula is 2 pi r. The 2 comes out in front because it's just standard to write it that way. 2 pi r. You can use either one for the circumference formula, pi times diameter or 2 pi r. Okay, again, they might give you some circles and they'll tell you the diameter or the radius and tell you to find the circumference. That's pretty straightforward. I'm going to do an example that's not as straightforward. It's kind of working backwards, okay? So let's check that out. It's similar to what I said a second ago about they might go ahead and give you the perimeter and you have to work backwards. So this is along those lines. The circumference of a circle is 426 feet. Find the radius to the nearest tenth. So you know the circumference already. They want us to find the radius. So I'm going to choose to use this formula for circumference, 2 pi r. And since they give me the circumference, I would then take the 426 and plug it in place of c, thus getting 426 equals 2 pi r. Now from there, you only have one option. You plug in 3.14 for pi. You can go ahead and take 2 times 3.14, 6.28, and that's times r. How do we solve for the radius from this point? Jared. Yeah, you divide both sides by 6.28. And when you do that, you get 67.834. And if I look at my directions, it says find that to the nearest tenth. So that means I want one decimal place. You look at the 3, and we would make it what? So it would be 67.8, and we would label it feet. 67.8 feet. And I did this purposely working backwards because honestly the straightforward problems you should be able to do with no problem at all. Write the formula down, plug in the dimensions of it, and evaluate it. Okay, once they give you the perimeter or the circumference, you do have to work backwards. Make sure you label all of these in units that are given. There's no square units in any of this because that would involve area, and that's not what this is. All right, questions?